We are continuing to fill out the IM2 Unit 1 test review sheet. We're on question number 4. If I can find my marker here, we can actually get started. There we go. Question number 4. Find the perimeter of the shape. Units are in centimeters. So we're looking for a perimeter, class. Just be careful here on these questions. Pay attention to whether it's asking for perimeter or area. So perimeter of the shape and units are in centimeters. I might as well go ahead and write centimeters over here since I know it's going to be in my answer anyway. And the perimeter of a shape is the measure of the outside of the shape, where you take all the side lengths and add them together. This one is particularly easy because all of the sides are either vertical or horizontal. Class, remember, please do not spend the time doing the Pythagorean theorem or distance formula when you have a vertical or a horizontal side. Those allow you to actually count the units because the distance or the length of that side can be seen in how many squares make up that particular side. So we got 1, 2, 3, 4, 5, 6 on the bottom edge. This is a rectangle, so that means the top is congruent. And 1, 2, 3, 4, 5, 6, 7. The side is also congruent since opposite sides are congruent. And perimeter just means add up all the sides. So the perimeter is going to be 6 plus 7 plus 6 plus 7. And that is going to be 23 centimeters. So answer for the perimeter for question number 4 is 23 centimeters. Let's take a look at question number 5. Find the area of the square. Units are in inches, and I know I'm finding area, so I already know my unit of measure is going to be inches squared, since area is measured in square units because it is two-dimensional. Now class, the underline is here for a reason. Please pay attention to it. By telling me this is a square, I know that if I just find the length of one side, I know the length of all the sides because the sides of a square are congruent. All the sides are congruent. So in order to find the area of this square, an area of a square is just like a rectangle or a parallelogram. Area is base times height. All I have to do is figure out base. When I figure out a base, then I can figure out my height. In class, the thing about a square also is all of the angles inside of a square, the interior angles, are right angles. That means I can treat any side as a base and then any adjacent side to that base as the height. Don't get thrown by the fact this square is not perfectly up and down or vertical and horizontal like the last one. It doesn't make any difference. If it's a rectangle or a square, we know we have right angles, and that means we can pick a side to be our base. We can pick an adjacent side to be our height. Let's find the length of this side, which we're calling our base. We're going to use Pythagorean theorem for that because it is not a vertical or horizontal side. Let's make a right triangle. The length of this leg is 2. The length of this leg is 1, 2, 3, 4. That means to find the length of our base, we're going to use Pythagorean theorem. 2 squared, oops, got a little delay here, 2 squared plus 4 squared. I'm going to move that down. Hold on a second. Let's put that down here. 2 squared plus 4 squared equals our unknown side c squared, which is our hypotenuse of our right triangle. This is 4 plus 16 equals c squared. 4 plus 16 is 20. So 20 equals c squared. So we know that the length of c is going to be the square root of 20, which is approximately, you know, I can get a decimal answer here of approximation, but I'm going to tell you right now, I'm not going to do that here, class. The reason why is this. Because if I know that the length of this side of the square is a square root of 20, that means my base is a square root of 20, and that means my height is also the square root of 20 because it's a square. All the sides are the same. So if I'm going to figure out area here, I can just do it this way. The area of this square is therefore the square root of 20 times the square root of 20. And think about that, class. I can write that as the square root of 20 squared. Isn't this just the same number multiplied by itself? That's what squaring means, is take a number and multiply it by itself. Well, we've already learned in class that a square root and a square, they cancel each other, which means the area for this square is just 20 inches squared. So the nice part about figuring out the area of a square is, if you get some square root as the value of c, you can just leave it as a square root, multiply it by itself, and the square root goes away, and you're left with the number inside. Now, just for the sake of argument, if you ended up on a test getting the approximate value for the square root of 20, and I got to tell you, I don't know what that is. Hang on one second, let's find it. So 20 square root. So it's 4.47, so we'd round it to 4.5. So we'd end up with 4.5. And if you use that to figure out the area, it'd be 4.5 times 4.5, and you would end up getting, let's check that out, 4.5 times 4.5 equals, and notice you get a little bit different answer, 20.3 if I rounded that. So it does introduce a little bit of an error if you end up actually resolving the square root and saying it's going to be an approximate answer. I would accept either one of these answers, but I would hope that you would use this method. It's faster, a lot less work, and you end up just canceling the square root with the square and ending up with an exact answer of 20 inches squared. Let's go ahead and go to number 6. Number 6, find the area of the triangle. We're doing area now. Units are in millimeters. That means my final units will be millimeters squared. And for a triangle, we know the area of a triangle is 1/2 times base times height. Now many of you are saying base times height divided by 2. Same thing. It'll work the same either way. Well, I'm going to pick a base that's either exactly horizontal or exactly vertical. This is my base, class. I can't use this as a base. I'll have no idea what the height is. Same with this, but I've got a horizontal side of this triangle. It'll also work with a vertical side. Let's use that and watch how easy it is. The base is 1, 2, 3, 4, 5, 6. And we'll draw a line from the base perpendicular to the top of the triangle. 1, 2, 3, 4, 5. The height is 5. So our area is 1/2 times 6 times 5. Put that in your calculator and you will get 6 times 5 is 30, divided by 2 is 15. So our area is going to be 15 millimeters squared. Let's go to question number 7. Number 7, find the area and perimeter of the polygon below. Units are in feet, so I know my area is going to be in feet squared, and my perimeter is just going to be in feet. Now I'm going to do perimeter first. So perimeter first. Perimeter is the measure of all the sides around the shape. So vertical and horizontal, all we have to do is count. Here is horizontal side, 1, 2, 3, 4, 5, 6. I've got a vertical side of 3. I've got a vertical side here of 3. And let's go ahead and figure out the length of this side, which we will use the Pythagorean theorem. Let's make a right triangle. We've got a leg of 1 and a leg of 1, 2, 3. So the length of this side, right here, we're going to use Pythagorean theorem. We know that 1 squared plus 3 squared has to equal our unknown side squared. 1 squared is 1, 3 squared is 9. 1 plus 9 is c squared. That means 10 equals c squared. So c is the square root of 10, which is approximately, oh boy, let's see, 3.2. Approximately 3.2. And now class, take a look. If I figure out now the length of this final side, you know what, let's label this one. I'm going to label it just on the inside here right now. Actually, I'll put an arrow here so I don't mess up the inside. That's 3.2. If I check the legs of this side for using Pythagorean theorem, I also get 1 and 3. And because that triangle that we make here to find the length of this side has a leg of 1 and a leg of 3. I guarantee you the length of that's going to be the same, because when you plug it in, it'll still be 1 squared plus 3 squared. So I already found the length of this side. That's also 3.2. And that means the perimeter is just adding all those together. So the perimeter is going to be 3, which is over here, plus 6, plus 3, plus, here is one of my sides, 3.2, plus my final side, which is 3.2. So my perimeter ends up being 18.4. So my perimeter here is 18, oops, that's an area, wrong place. Perimeter is 18.4 feet. Now let's do area. This is a composite shape, and that means I need to divide this up into two shapes that I can find the area of. That's easy enough. I'll draw a horizontal line right here. We've got a rectangle on top, which is 3 units tall and 6 units wide. So this is going to be 3 times 6, which is 18. So the area of the rectangle is 18. The area of the triangle is 6 is our base. If we look at a horizontal side of that triangle, 6 is our base and 1 is our height. So let's figure out the area of the triangle, which is going to be 1/2 times 6 times 1, which is equal to 1/2 of 6, which is 3. So the area of this triangle is 3. And we know the area of the whole shape is adding those two numbers together. So the area, I'll just put area sub t for the total area, is equal to 18 plus 3, which is 21. So the area of this composite shape is exactly 21 feet squared. We'll continue with question number 8 on the next video.